If you recall, last week we talked about Leach's rules for addition, not because I came up with these kind of rules. I'm just trying to take what we already understand about addition and state it explicitly. So that means we only add things that are the same, and when we add them, it doesn't change what they are. This is just stating explicitly what we already understand about addition. Then our goal becomes to identify what we mean by sameness in various contexts. The one I usually pick is $5 plus $3 is $8. Here, the 5 and the 3 both represent dollars. So we can add the 5 and the 3 and come up with $8. And it stays dollars because when we add things, it doesn't change what they are. It would be a horrible world if I had $5, someone gave me $3, and all of a sudden I had 8 pencils. You don't want to add things and have it change what they are. So taking that idea, that applies to fractions. Sameness in fractions is a common denominator. So 5 11s plus 3 11s will be 8 11s. The denominator tells us what kind of fraction they are. In terms of algebraic objects that we're going to have to get used to, in terms of polynomials, it's like terms that indicates sameness. So 5x and 3x is 8x because they are like terms. We have the same variable, same variables with the same exponents. So not like terms would mean the variables aren't the same. 5x plus 3y, we don't add those. We don't have 8 of anything because those are not like terms. We also need the same exponents. 5x squared and 3x, we want to identify those as not like terms. The variables are the same, but the exponent is different, and that makes them different and not like terms. Next, we started thinking about multiplication. And so we looked at an example, and I'm just going to jump into fractions again. I had asked you to add 5 7ths and 3 11ths. And what did we have to do to add those together? So in this case, I couldn't add the 5 and the 3 because in terms of fractions, I had different denominators. And so I did not have the sameness. But also in this case, we can use multiplication to get sameness. We multiplied by 1, but kind of a special form of 1. I multiplied 5 over 7ths by 1, but in the form of 11 over 11. And I multiply the 3 over 11 by 1, this time in the form of 7 over 7. This will give us a common denominator of 77. That means we get to add them as fractions, but it's no longer a 5 and a 3. We did the same thing when I tried to add $5, when we tried to add $5 and €3. I couldn't add the 5 and the 3. I don't have 8 of anything here, but if I get a common currency, then I can. So if I take the $5 and convert my €3, I think it was 1.22. I use multiplication, $1.22 per €1. Now I will have the same currency, $5 plus $3.66. And so I can add them and come up with $8.66. So in these two cases, we use multiplication to get sameness. All right. The other thing that we want to think about when we're thinking about multiplication is multiplication as an operation. Multiplication is repeated addition. If we're adding a bunch of things that are the same, we want to gather that up with multiplication. And then the example that we looked at last week is if I have 5 plus 5 plus 5, I'm adding a bunch of things that are the same, so I'm going to use multiplication to summarize it. Multiplication is a summary of a bunch of addition. We use multiplication to summarize this repeated addition. But if things are different, then that would not be adding things that are the same. So that's not the same addition, this repeated plus 5. So this would not count as multiplication. So we want to think of multiplication as repeated addition. Any questions before I combine the two together? So at this point, we had two questions for the future. So we wrote down two questions for the future, and that would be, what about subtraction and what about division? Those are supposed to go with addition and multiplication. We got to have subtraction and division. The other question is, how do multiplication and addition combine together? More than just multiplication is repeated addition. Let's look at the second question first and talk about addition and multiplication combined together. Let's talk about combining multiplication and addition. Any questions before we start combining multiplication and addition? Great. There are two things that we want to think. Two things? I bet there's three things. I might end up Spanish Inquisitioning myself. But let's start with two. There are two things that we want to think about when we start combining addition and multiplication. And they are, of course, related. So, first thing, multiplication goes before addition. First things first, multiplication goes before addition. You'll remember this from the order of operations, but you also might remember that the order of operations is PEMDAS, and PEMDAS is trash. So PEMDAS is bad. Don't do PEMDAS. Or in the UK, don't do BODMAS. So PEMDAS is trash. Just fight me. Anybody that's like, oh, do PEMDAS. That's how I, by the way, how I identify who the robot is. Because they're like, oh, no, PEMDAS is better. So what I mean when I say multiplication goes before addition is that if I've got, for example, is best with just an example, if I've got 5 plus 3 times 7, the multiplication comes first. Multiply first. So in the expression 5 plus 3 times 7, multiplication goes first. 5 plus 3 times 7, which is 20 something. 21, yeah, thank you. So 5 plus 21, and then 5 plus 21 is 20 something again. Is it 26? I'm not very good at arithmetic, so. Now you might look at this and say, isn't that just PEMDAS? And I'll be like, oh no, there is no PEMDAS in this room. This is just multiplication goes before addition. Let's talk about why this makes sense. This is not just some random rule where we decided that multiplication should go first. 3 times 7 means I've got 3 7s lined up, or 7 3s. I'm going to go with 3 7s because it's less to write. It means there are 3 7s lined up in an addition here. It's summarized something for us, so let's figure out what that is first. So 5 plus 3 times 7. So let's talk about why this makes sense. It's not just an arbitrary rule. It makes sense. I don't know if this was blurry or if it's just me. I think it's just me. 5 plus 3 times 7 means 5 plus 3 sevens. Or 7 threes, but 3 sevens. It represents an addition. So let's take it. That multiplication represents an addition. So let's take that summarized addition first. This has been summarized with multiplication. So we'll do the summarized stuff first. Also, we could think we don't want to do the 5 plus 3 because I don't have a 3 here. This is not just a 3. This is 3 sevens, 5 and 3 sevens. So if I say I have 5 and 3 sevens, I don't have 8 of anything because I have 5 ones and 3 sevens. I don't add things that aren't the same. I got to convert them into the same thing. 5 ones and 3 times 7, 21 ones. Now I have 26 ones. Now they are the same. Any questions? That's a fairly hand-wavy justification for doing multiplication before addition. But it has more context than just do PEMDAS. Because you're not robots. You're better than that. You have human brains. So I think it makes awesome sense that multiplication goes before addition because multiplication is like summarized addition. Let's take care of that summary first and then do the rest of the addition. It's like we've shortened up all of that addition into a multiplication. So let's take care of that first. If we want to read this as a 5 plus 3, we have to recognize that there are 7 of them. So we could also write this or 7 threes. Now I regret using a 7 and not a 2, but oh well. 1, 2, 3, 4, 5, 6, 7. Oops, I said 7 and I wrote 7. 3, saved it. That's a 3. So 3 times 7 is 3 sevens or 7 threes. Any questions? So when you got to make a choice, multiplication goes before addition. If we want to change the order, what do we have to use? Because I'm betting a lot of you know this already. If we want to change the order, if we want the addition to go first, then what do we need? What do we use if we want the addition to go first? Parentheses. Parentheses is not an operation. It's just a way of saying, hey, do this first. That's why I don't like putting it in the order of operations. If you put in all your operations in an order, those things should all be operations. Parentheses, not an operation. But we use parentheses. So if I write 5 plus 3 times 7, the multiplication goes first. 5 plus 21 or 26. But if I want the addition to go first, I'm going to go, no, I have 5 7s and I want 3 7s. I use parentheses. 5 plus 3 times 7. The parentheses say to do the addition first. So 5 plus 3 is 8. And 8 times 7 is 50 something. The parentheses say to do things in the other order. The parentheses are saying do this addition first, then multiply by the 7. Without that instruction, we do the multiplication before the addition. Parentheses say do the addition before this multiplication. Any questions? So with the parentheses, it's not just 5 and 3 7s. It's 5 7s and 3 7s, which brings us to the other combination of multiplication and addition. So part 2 of combining multiplication and addition, we say the following. Multiplication, oops, I'm off the page, there we go. Multiplication distributes over addition. This is the distributive property as is commonly presented. But the problem I have with that is they say the distributive property. And it's specifically the distributive property of multiplication distributing over addition. So this is a familiar scene. This is where we normally summarize in formulas, which is a really bad habit on our part, but we say A times B plus C is equal to AB plus AC. This, I hesitate to write this down. I only write this down because this is probably how you've seen the distributive property before. I want to say that is the thing that we are using. But by writing the distributive property this way and telling you back when you were children, this is the distributive property, you start interpreting parentheses to mean this, and that is not the case. This only works because we're saying A times B plus C. This is multiplication distributing over addition. So that means I can do the multiplication, and I have multiplication here and multiplication here. The other bad habit that we have as math people, as mathematicians, we're all mathematicians now, is that when we just write two things together, it means that we're multiplying them. So AB means A times B. And so A, then parentheses, means A times the things in those parentheses. The problem is we always just write them together, and so we stop thinking them as multiplication. We stop thinking of this juxtaposition as multiplication. But we really need to think about this distributive property by thinking that multiplication distributes over addition. We actually can use this in the previous example. We have 5 plus 3 times 7. This is going to be 8 7s, and that's the same if we use the distributive property as 5 7s and 3 7s. So this is the same as 5 times 7 plus 3 times 7 if we use our distributive property. If this multiplication distributes over the addition, I can distribute and say it's 5 times 7 plus 3 times 7. 5 7s and 3 7s is 8 7s. 5 sevens plus 3 sevens is 8 sevens. Or I could say 5 sevens is 35, 3 sevens is 21, and 35 plus 21 is still 50 something. So multiplication goes before addition. If I want the addition to go first, then I need to use parentheses. Multiplication distributes over addition. That's how we can remove parentheses if we have multiplication and addition. So we need to use parentheses to change up the order. If we want to reinterpret what the expression means, we can use the distributive property of multiplication over addition to remove parentheses. So we can use the distributive property to remove parentheses and then reinterpret what the expression means. So this says 5 plus 3 times 7. That means the same thing as 5 sevens and 3 sevens. Any questions? So these are how we want to think about addition and multiplication combining. We want to think about multiplication distributing over addition. That's how we can remove parentheses. We also want to think that multiplication goes before addition. And we have to use parentheses if we want the addition to go before the multiplication. And then we want to combine that with our two rules or two things to remember about multiplication. That multiplication is repeated addition, and that we can use multiplication to get sameness. Then we want to think about our two rules for addition. We only add things that are the same, and when we add them, it doesn't change what they are. How's everybody okay? It's hard to tell. I'm just like looking at like a big old list of names and a screen and stuff like that. So school is weird these days. Great. So the next thing we're going to do is you should expect another page to show up about addition and multiplication together, which will summarize these notes. And you should probably expect another quiz that involves multiplication distributing over addition and rewriting things with parentheses. So we're going to do, let's do another example where we have an addition and a multiplication combined. So let's suppose that I have 23 plus 5 times 6. What goes first in this expression? What do we do first?
Five times 6.
First, we're going to do 5 times 6, and that's going to give us a 30. And then we've taken care of the multiplication. And then finally, we can do 23 plus 30, which is something. I had to pick something that came up with a 0 so I could actually do the addition. So 2 and 3 is 5. If I wanted, instead, if I look at the result and say, oh, I didn't want just 5 6s, I had 23 6s. What if I wanted the addition to go first? 23. I wanted 23 plus 5 because that's how many 6s I had. So what do I have to do?
Put it in parentheses.
Got to put the 23 and the 5 in parentheses, and that'll say do this addition first. And 23 plus 5 is 28. Because we actually had 23 6s and then 5 6s. So 28 times 6 is, 28 times 6 is, dang, I need to redistribute. How much is it?
128.
120. Well, with 6 20s is 120. And 6 8s is 48. So I think, is it 168?
Yeah. 168.
So, yeah, 168. So this gives us an idea about how we can best use the distributive property to help us with things like 28 times 6. So 28 times 6, I can think of this as 23 6s and 5 6s. I know 5 6s is 30, but 23 6s, yeah, that's kind of messy. If I take these 3 of these 6s and push them over to the 5s and reimagine what's going on here, I could think of this as 20 plus 8 6s. And then the distributive property will help me out. I like multiplying things when there's a 0 at the end of my number because that's 120. And 6 times 8 is 48. So 120, 48 plus 48 is the 168. What we're trying to do is not do something like say, this is the way, or this is the way, or setting up a 28 times 6s in a stack like we do, right? 28 times 6. 6 times 8 is 48. I'm going to write it in this really weird, funky way, but I was programmed to do that as a child, so I'm still stuck with that. Then I do 6 times 2, but plus the 4 because, you know, weird algorithms. 6 times 2 is 12 and 4 is 168. We're not saying this is the way, or this is the way, or just knowing this is the way. We're trying to give us more options so that we can be flexible, so that we can make more connections, so that we can understand things better. Does that make sense? Too often I see arguments against doing this as if knowing something is worse, as if knowing something is a negative. Knowing something is never going to subtract. And usually I see demonstrations like, oh, well, this way is faster, right? People are like, oh, well, this way is faster. And then they show, it's like, oh, see, I did this much faster than you did it over here. And it's not about speed. And second of all, the reason that you're really fast with this is that you were programmed with this as a child and you've been doing it since then. And now you're trying to learn something new. And so, yeah, you're going to be slower at it. So anyway, mostly that comes from parents. And the reason that I teach in community college is that I don't have to talk to your parents. So your parents would be calling me up like, well, how's little Johnny doing in school? And I'd be like, well, I don't know. You don't have to ask little Johnny. I am legally stopped from talking to you. Any questions? Comments? Snide remarks? All right. So once again, I'm not taking this and saying this is something
I'm
new.
looking for.
What's that? We're not saying this is something new. What I'm doing is taking all the stuff that you already know and trying to add to it. We're trying to put those things together. We're trying to enhance what you already have so that'll be more useful to a more useful foundation on which to build. And that's the goal. All right, our next meeting is going to be tomorrow. So remember, this class has two parts, has the 1:20 part, which is the Monday, Wednesday, Friday meetings, and the 8:20 part, which is Tuesday and Thursday meetings. All the meetings are optional. They'll all be recorded and all the notes will be posted. So if you can't make it on Tuesdays and Thursdays, that's okay. We're just going to be going over some more problems that have to do with multiplication and addition combining together. All right, that's going to do it for today. I'll see y'all on tomorrow or Wednesday. And thanks for playing.
Thank you, Professor.